Ilari Lähtemäki, and welcome to join today's webinar, where we are going to tell you some principles, practices with concrete examples on the subject of how to store research data. We'll think about how the data will be safe, sound, usable, accessible, available, even long term, and also a little about how to preserve the confidentiality of data. And we also give some practical examples for cross-organizational collaboration project using cloud services, or how using a network drive and how to organize your files and store your data in there as a practical examples. To begin with, one first basic principle: good storage service. It's just a start for you, but good practices are actually the key to avoid problems. So it's not that much about what you use to store your data, but how are you actually doing it? Makes a big difference.
So in this part, we will have some problems, or I will have some problems, and Ilari will probably have some good answers on how to avoid them. So in this first one, it's about organizing your data. I had a figure in one of my articles some time ago. Now someone has made a cure about the figure, and I need to review it to the raw data I used to create it. The project where I did the measurements ended 2 years ago, and I don't remember exactly where the data is. There is a lot of data in the project directory that was never cleaned up after the project. So where was that file again, and what could be a good practice to avoid this the next time?
Yeah, sorry to hear about that problem. Most important thing you should have a name of the file. So what was actually the name for your raw data, and try to have a descriptive and unique name, so that then you could even use like a search with your computer for laptop easily by entering the file name. So if you have to search for something that's named called data, and you have used the same name in very many projects, then you will get a lot of results to go through. But if you have a project name, year, these kind of things already in a file name, it will make it a lot easier for you to use, for example, computer search for finding the file. And if you have a good subfolder structure that you can easily separate, you can find, okay, it was that project, you'll find a project folder with your name, and then you have, for example, different folders for raw data, process data, articles. You can quickly go through your folder and structure and easily find a scheme also afterwards. And even better, if that's agreed with your group, then you can also locate a file from your team member. Perhaps the raw data was created or accessed by someone else in your team, so you can even find the file easy from another person's folder who may not be even in the group anymore. And as last practical tip here, why not to include all of this to a data management plan that can actually support then your group everyday work. You can have a data management plan just for your group, in addition to the one that is usually made during the funding applications. But a data management plan would be a concrete idea, an example of this kind of a document that you can use to agree file structure and other what storage services you use with your group.
Okay, so here we have a practical example of what we just talked about. And this is only an example, so every team should replan their own system. And it can also, of course, be based on project. So each team may have several plans and several directory structures. But take some time to plan ahead and don't just start storing, because that will end up in a mess if you don't plan ahead. And this example is from the Aalto internal teamwork storage service, but the same requirements apply to almost any storage system. So name the files and folders descriptively and think about how they sort so that they stay findable. File names could include things like name of the task, date, in year, month, date order for sorting, language, version number, or something else that you find relevant for your team. And remember that also the order of the attributes affect how they sort. And one important thing is to separate administrative data from research data. This is important because they are usually on different levels of confidentiality, and they should not be available to the same people. And also the size of these types of data may be completely different, so the same storage system might not be the most optimal one for all of them. Then we should have the next example problem, this time how to ensure access. So one of the researchers in our group recently left the university. Now I have been assigned a task to take care of his part of the research in the project. And I think I know where the research data is stored because it was written in the project data management plan. But when I try to access the folder, there is an access denied error. So what could be wrong?
Yeah, you probably need to contact IT support to solve the actual problem and get to access there. But what you can do better in the long run would be to store all the research data in a shared group directories from the beginning. So that even if you would have a personal folders for each of the group member and team member and research team, that they would have easily a personal folders for each user. The access could be so that anyone in the group can have read-write access to those folders. So whenever someone leaves or somebody needs to hand over the work to someone else, there's always access and the data is available. So that's easy. There's nothing special to do for the sharing. The data is already shared. It will be available for anyone who needs it. And also as long-term continuity, when people come and go, the data will stay within a team and be available, but still you can organize your work and your routines by users and by individuals if you like to. And for Aalto University, we have a home directory. If you are doing your individual work just by all alone without any research group, then you could have used that one also. But for other purposes, teamwork or Drive as a shared group directory in a cloud or in network drive is the best option to go. And then it's also important to know who's the owner of the data and who will actually manage the access and can give an access to a team folder or certain project folder. And also decide that some data is no longer needed.
But then we have something on cleaning up your data. So this time I'm looking for the final version of a data file that was used in an article published 4 years ago. And I need the final version to repeat the simulation and check the results. And the project was finished and the results published. We were in a hurry to get on with the next project. And there were hundreds of data files and we had no time to go through them back then, and we never got back to do this. All the data was just transferred to an archive folder as such, with all intermediate data and unused data left there. Now I open the folder to check, and it will take days to make sure which file was the one I used in the article. So how should we try next time to avoid such a mess?
And try to remember to clean up your data and reserve time from the cleaning already for the project plan. So either have weekly routine even, or if you would like to do everything at once at the end of the project, then just reserve a day or two for that. So just clean up the data, remove intermediate data would be good. You can support that even in the folder structure, that you have a separate folders for the data that should be archived and kept for a long time, and another data for working files that you can then go and purge at the end of the project. And it's good to have a separate, for example, we have project folder and archive folder tree for the project that is ended will be moved from the project root folder to archive project. So they will be stored in separate locations. And also good tips are to remove personal data when the purpose for handling it expires. So that's something that you can do during the cleanup to check if there's some data that should not be kept any longer. And then have an archive folder for the data that you wish to keep for further purposes. And one way to archive data and keep it tight is to publish it. So you can publish in your data repository the anonymized dataset for further use for anyone, and also including you.
So now we still have one example on backing up data, and here are a couple of cases which might happen. So I was working on my thesis using my laptop in a cafe this weekend, and I forgot it there. The thesis data was stored on the laptop, and now it's gone. And then there also was another colleague whose laptop was broken, and he brought it in for service. But the laptop had to be reinstalled, and now all the data is lost. So what went wrong here?
Well, these are the unfortunate real-life examples that stress out the importance for making sure that you will have backups of your data. And the best approach to get backups is to have something that makes them automatically. So if you have to handpick the files or remember to do a backup routine yourself, that very often they might get delays and you might lose weeks of work. And here at Aalto University, our network drives are automatically backups. They're good for that purpose. And most of the cloud storage services are also reliable, and you can have the data there. And at least if your laptop breaks, the data is still safe in a cloud. So that's a lot more reliable as a storage service than having the data only at the laptop. And also not having the data in a USB drive or external drive, only copy of your data in a OneDrive in this kind of one single USB drive. That's something that you should avoid, but try to have it somewhere where it's just been backed up automatically.
Okay, so then a bit on how to collaborate between organizations using the cloud. Here we have a case where we need to collaborate and share data with people in other universities and businesses. And Aalto coordinates the project with participants from other universities and companies in Finland and in Europe. And one of the conditions is that the data has to be stored in the European Economic Area. So we select Microsoft Teams as tool for collaboration, and we check the license terms of our Teams agreement to make sure that the data stays in the EEA and that the security level is okay for our data. And we will use Teams for chat, meetings, and to store the project data. And in Teams, there are private spaces and private channels inside the spaces that can be used for smaller subgroups. And to keep in line with data confidentiality, only shared files and folders with identified users. Open links without requiring user authentication is okay only for public data, since the link may easily spread and could be used by anyone if it's just an open link that works without any authentication. And Teams is also good because it's supported on many platforms like Windows, Mac OS, Linux, as well as Android and iOS. Then we should still have something on sharing in Microsoft Teams. So a practical example on how to share. So sharing is usually controlled by membership in the team. And this slide shows how to control membership. And we start from the team selection grid or list. And then to add, edit, or remove team members, we click the three dots after the team name. And we select Manage Team. And then a new window opens where we can add, edit, or remove users, and that's the one to the right. And we can think that unless data is public, the safest way is to have only team owners adding members. And this setting is also found by clicking the three dots after the team's name and selecting Edit Team in the menu. This opens the team's details window with the privacy setting, where private is the recommended setting. In Aalto, Teams is configured not to allow sharing with link only by default, but that may be different in other organizations, so make sure that it works as you thought. The safest way is to specify people to share with, so no open links. And there are also more advanced settings available through the SharePoint user interface, but we won't go through that now. So then something on long-term availability in cloud. Ensure that your team has access to the data for the duration of the project or however long it's needed. And prefer services that uses team folders like Microsoft Teams. Don't use a service that is based on one person sharing the data from hers or his account. If that person leaves the organization, access to the data ends for the whole team. We have several people with full owner rights in the shared folder. This is also to prevent problems if one of the owner leaves the organization. And if storage based on individual accounts is used anyway, make sure to transfer all data to another owner if the previous one is going to leave. That has to be done before he leaves, because after that it's not possible anymore. And after the project ends, we also need to ensure long-term availability, probably with another service. So plan ahead and think about who should have access to the data after the project, and also how to keep the access rights updated after the project. Using a data repository to provide long-term access is the best way and recommended way. The data can be public or restricted also in the repository. And cloud is reliable as storage technology, but some risk remains. Any accidentally deleted file is permanently deleted after a certain time. In Aalto, that time is 30 days, but that may also vary across organizations and how they set up their services. And network problems may cause short-term access problems, but they can be mitigated, for example, by using laptop synchronization to ensure that data is also available without network. And the service might end someday, for example, if the agreement for the service ends, which might happen because of cost increase or something like mergers or political issues, or just changing to another service.
Yeah, so thanks, Dan, for sharing these examples on cloud collaboration. And then there are some basic principles about how to classify data and how to deal with confidential data. So at Aalto University, we have specified 4 levels: public, internal, confidential, or secret. And there's information and guidelines for at Aalto that define how to classify for these that apply to Aalto University. And also a list of IT services maintained by cybersecurity team, a huge table that way you can check which IT services are approved for which data categories or classification options. So when after you have classified your data to be internal, then you can check what are the services that you can use with internal for example, confidential data. Basically, the setting classification scheme the details might vary between organizations, but usually there are public data that is okay to be shared, can be given on request. If someone needs to something internal that is specified for the organization only, or for example, everyone at Aalto University, that's large community anyway. And confidential and secret are more and more restricted and more limited to people who should have access to that information. And about confidential data, that's only for specified people who need the data at their work. And usually that's a list of people that you can name and list everyone when you have the level of confidential data. And there are usually some background or some reason why data should be confidential. So it might come from legislation, some agreements, research agreements made with data owners or companies, or data owner might tell that, okay, we can give the data for research purposes, but only for you and your project team and no one else. Or then this organization will decide that, okay, we keep this data as confidential. I know examples that we have at Aalto University. So personal data of research subjects is something that we as an organization have decided that this should be confidential, and is also highly regulated with the legislation as well. So it's not only up to research or Aalto University to decide confidentiality of the personal data. And trade secrets of research partners are usually set this confidentiality by the partner in question. Sometimes there are also commercialization potential for Aalto University, and commercial interests might be for Aalto University to keep some data confidential, for example, prior to filing the patent application. And also some research results before getting the article out might be confidential first, and then the confidentiality may change to public when the article has been released and published. And how you can keep the data confidential while storing it. Make sure that everyone who has the access knows what are the restrictions and how they can share data or if they cannot. And the access restrictions would be kept up to date. You have set them up, for example, in Teams, it's a private Teams. And if the people come and go, you will remove the access for the people who have gone and add new people's. And try to also ensure the correct identity, for example, the email address, so that it's not just someone with the same name using a mail service, but it would be actually the one you are collaborating with. And then requiring login while sharing data is also good. Open links that work for anyone, then anyone can access it, or if they only get the link for themselves. But if there's a login required, it will be always more secure for the confidentiality point of view. And you can even use a separate encryption for the data to add some security. So there would be a separate password needed to open or decrypt, understand the data, even if there would be accidental access for someone else. And for example, how to share confidential data using Microsoft OneDrive, Teams. You here click on the folder, for example, with the right button, select the share. You can from Windows get to the share window, and then you can here find a setting, who is the target group of this share and this link. So you can click this text and have a choice. So using the people you specify can edit, then you can write name by name the people you can, and only those people can then use the link. But if you choose something like people in Aalto University or anyone with a link can access, then that's only good for public data. But for confidential data, you should have a specified list of named people and use that for sharing. And then only the recipient you have given here can actually use the link. No one else, even if they can see or click the link, but they cannot get access. So that's the safe way to share confidential data. And that default setting might also vary from organization to another.
Okay, so then we still have the Teamwork, which is an internal storage service in Aalto, and it can be accessed also from research workstations in closed network, also those that can't access the cloud. And in Teamwork, user access is controlled by the IT service desk or the department admins. This is a bit less agile than the self-service system in cloud services, but it also provides an extra check that everything goes to plan and confidentiality is maintained. Access can be granted only to people with an Aalto account, and external collaboration is not directly supported. It's not completely impossible, but it's not readily available. So use cloud services for that. And data can be used remotely using VPN connection. And the backups in Teams can be customized, but for example, by default, snapshots are made hourly during daytimes on work days. And also backup to separate media is done once a week. And there are more details on the backups if you follow the link. And then we still have a practical example of how the storage services look on a Windows workstation here in Aalto. So the storage services are available directly from the workstation, exactly as any storage device. So if we can show in the picture different services, we can see home directory, and then Teamwork, OneDrive. Microsoft OneDrive is up there, and Google Drive and also Dropbox are in the picture. And the important thing is not to store data permanently on the internal drive of the workstation, because the internal drive is not backed up and the data is lost in case of malfunction or if the workstation is reinstalled. And reinstallation is quite a common way to get things to work if there are more severe problems. So it's actually a quite possible scenario. But the internal drive can be used for temporary storage. For example, if some analysis, software, or some simulation requires very frequent and fast access to the data. But in that case, copy the data back to one of the storage services immediately when the analysis is finished.
Okay, and then to wrap up, we have an example of a table of different storage services available at Aalto University. And then left with the question at present is all of the we have discovered so far what actually to use with your research project. And there are many things that you can think about. For example, starting with the capacity, how much space do you need? If you need large space, we can provide that at Aalto University using Teamwork. Or for example, for the cloud, we have the largest volume available using Dropbox currently. And for publishing large data sets, the Fair Data IDA service is recommended. If you need to work with confidential data, then the Aalto network drives are the most secure option. And they also give you best performance for you, as they are the closest one, and you can have those to support different research devices similar. And for students, then the services are a little bit more limited than for the other personnel. Students can have access to the home network drive they can use for individual work like thesis, it's backed up. And they have also access to cloud services, Google Drive, Microsoft Teams, Microsoft OneDrive. And for example, if you had Aalto research project that you need to share the data only internally within your research project, the recommended option would be Teamwork. That's automatically backup. There's a lot of capacity we can offer you, and everyone can easily have access there. Also promoting for the long-term continuity. And if you need to share data with somebody outside of Aalto, then you can use cloud services, Microsoft Stream, Google Drive, Dropbox. The choice depends on what are the collaborators using. Also, Fair Data IDA can be used during the project and the collaboration phase, and later on publishing the files there. And there's also Microsoft-based eDuni service run by CSC available. But compared to Microsoft Teams, for example, the eDuni has a little bit more limited storage space available. So, for example, collaboration, I would recommend starting with Microsoft Teams for Team or OneDrive with the single files sharing. So to wrap up this session, your data is the most valuable asset you have, so take good care of it. Choose a good storage service, but don't worry, we will help you there. We have the tools and resources to help you, and just contact us with your data needs, and we will figure out the best storage solution also for you.